Hello everyone, hope everyone doing great. Welcome to Python for Data Science Prasanna Tech channel. Before we delve into today's topic of control structures in Python, I would like to kindly remind you to take a moment to watch my first video if you haven't already done so. It will provide you with a solid foundation for the concepts we will be covering today. Once you have done that, feel free to continue with this session where we will be exploring the various control structures available in Python and their applications. Let's now delve into the topic of relational operators, which are a fundamental aspects of programming in many languages, including Python. Relational operators allows us to compare values and expressions, and they are essential for creating decision-making statements within our code. So let's get started by discussing the basics of relational operators and how to use them efficiently in Python. Relational operators either returns true or false according to the condition. These operators are also known as comparison operators. The first relational operator is the equals to operator, denoted by two consecutive equal signs in Python. It returns true if two values or expressions are equal and false otherwise. Let's see how this works through an example. A equals to 10, B equals to 9. Print A equals to B. So it is going to return false because A and B both are not equal. Next, not equals to operator. It is going to return true if operands are not equal. Let's take an example. X equals to 10, Y equals to 6. Print X not equals to Y. So it is going to return true because both are not equal. Next, greater than operator. It is going to return true if the left operand is greater than the right. Let's take an example. A equals to 9, B equals to 5. Print A greater than B. Less than operator, it is going to return true if the left operand is less than the right. Let's take the same example. A equals to 9 and B equals to 5. Print A less than B. The result is false. Next, greater than or equals to operator, it is going to return true if the left operand is greater than or equals to the right. Let's take an example. A equals to 10, B equals to 5. Print A greater than or equals to B. Less than or equals to operator, it is going to return true if left operand is greater than or equals to the right. Let's take an example. A equals to 9, B equals to 6. Print A less than or equals to B. Shift plus enter, you'll get the result that is false. Python decision making involves using conditional statements to execute different code paths based on specific conditions. Example, create a program to determine positive or negative number using decision making in Python. So let's create a variable num equals to int input enter a number. So we are going to take the data from the user. If num greater than 0, here we have three conditions. If num greater than 0, then you have to print the number is positive number. So if the number is greater than 0, then we call that is a positive number. So whatever the number the user is going to enter, it is going to check whether user entered number is positive or negative or 0. So next, if num less than 0, print the number is negative because whatever the number we are going to enter there, if it is less than 0, then that's a negative number. Else print the number is 0. If I enter 3, then it is going to return the result as positive. Now let's discuss about logical operators. Logical operators are used to perform operations on values and variables. These are the special symbols that carry out arithmetic and logical computations. The value the operator operates on is known as operand. In Python, logical operators are used on conditional statements, either true or false. They perform logical and, logical or, and logical not operations. Logical and. Logical operator and returns true only if both the operands are true, else it returns false. It is a binary operator, which means to return some value, it has to be operand between two operators. That is, two operators are required. You can check the truth table here. So let's take two inputs, that is operand 1 and operand 2. Output you can check in logical operand result. This is the flow chart representing the AND gate. Now let's take an example. A equals to 10, B equals to 15 and C equals to 9. If A greater than B and A greater than C, print number A is larger. LA greater than A and B greater than C, print number B is larger. If C greater than A and C greater than B, print number C is larger. Next, let's discuss about logical OR operator. The logical operator OR returns false only if both the operands are false, else it returns true. It is a binary operator, which means to return some value, it has to be operand between two operators. That is, two operators are required. Now let's check the truth table for this. Operator A, operator B, both are inputs and logical OR result is the output. And let's check the flow chart for this. Now let's check an example. A equals to 10. If A equals to 10 or Prasanna Tech channel, print it's awesome, else print try again. Next, logical NOT operator. Logical NOT operator works with the single boolean value and returns the value as true if the boolean value is false and vice versa. That is the opposite of it. It is a unary operator, which means to return some value, it has to be operand on one operator only. That is, only operator is required. Let's check with the truth table. Operator A is the input, logical NOT result is the output here. Now let's check the truth table here. Now let's take an example. A equals to 9. If not A equals to 9, print A not equals to 9, else A equals to 9. Next, identity operators. Identity operators are used to compare the objects, not if they are equal, but if they are actually the same object with the same memory location. So first is, it is going to return true if both variables are the same object. Now let's take an example. X equals to, in square brackets, inside quotations you have to write apple, comma, banana. Y equals to X, print X is Y. It is going to return true. Next is not operator. It is going to return true if both the variables are not the same object. Let's take the same example. Print X is not Y. It is going to return false. Let's discuss about bitwise operators. Bitwise operators are used to compare binary numbers. There are 6 bitwise operators are there, as you can see here: AND, OR, XOR, NOT, zero fill, left shift, signed, right shift. AND operator sets each bit to 1 if both bits are 1. OR operator sets each bit to 1 if one of two bits is 1. XOR operator sets each bit to 1 if only one of two bits is 1. NOT operator inverts all the bits. Zero fill, left shift. Shift left by pushing zeros in front from the right and let the leftmost bits fall off. Signed right shift. Shift right by pushing copies of the leftmost bits in from the left and let the rightmost bits fall off. Now let's take an example of bitwise AND operator. Print 6 and 3. It is going to return the result as 2. The AND operator compares each bit and set it to 1 if both are 1. Otherwise, it is set to 0. Now let's check the example for bitwise OR operator. Print 6 or 3. The OR operator compares each bit and set it to 1 if one or both is 1. Otherwise, it is set to 0. The result is 7 here. Now bitwise XOR. Print 6 XOR 3. The XOR operator compares each bit and set it to 1 if only one is 1. Otherwise, if both are 1 or both are 0, it is set to 0. Now the result is 5 here. Now let's discuss about bitwise NOT operator. The NOT operator inverts each bit. 0 becomes 1 and 1 becomes 0. So print NOT 3. The result is -4. Now 0 fill left shift. Print 3 left shift 2. The left shift operator inserts the specified number of zeros, in this case 2, from the right and let the same amount of leftmost bits fall off. Print 3 left shift 2. The result is 12. Signed right shift. The right shift operator moves each bit the specified number of times to the right. Empty holes at the left are filled with zeros. Now let's take an example. Print 8 right shift 2. The result is 2.